Okay, today is the 20th. It's Wednesday, February 20th. And I'm going to talk to you a little bit about the sum and difference formulas on the formula chart. So if you look at your yellow formula chart here, it's these formulas down at the very bottom left that we're going to be working with. And we're also going to look at the cofunction identity a little bit. We're going to use these to prove the cofunction identity. But you'll see that sine of an angle plus an angle equals sine angle, the first angle, times cosine the second angle, plus cosine the first angle, sine the second angle. Hopefully you're looking at your yellow, because I don't think you can see this very well on the screen, but that's okay. You can be looking at your chart. Notice that on the cosine, if you add an angle here, then you're going to subtract it here. That negative plus, the minus plus tells you that these two will be opposite. Same with the bottom of the tangent sum and difference formula. The top will be the same, but the bottom will be opposite. So let's work through a couple of these and you'll see how they work. If it says find the exact value of cosine 75, notice this is an angle that's not on your unit circle. It's not one of your common angles, so we can use the sum or difference formula by figuring out a couple of angles that add up to 75 degrees. So hopefully you would notice that you could use 45 and 30. So cosine of 45 plus 30, so we'll just plug it into the formula. So cosine 45 times cosine 30. Because it's cosine, we need to subtract there, and we can say sine 45 sine 30. And so that would equal square root of 2 over 2 times square root of 3 over 2 minus square root of 2 over 2. Sine of 30 is 1/2. So I get square root of 6 over 4 minus square root of 2 over 4. And you can put those together if you want. Since we have a common denominator, we end up with square root of 6 minus square root of 2 over 4. Now here you can do the same thing with radians. Now my thought process here is, if I'm looking at a unit circle, I know 1/12 of a pi, or pi over 12, is right there. So I need to take an angle here and subtract something to get to pi over 12. So you may have to play with it when you're dealing with radians. It may not be as easy for you. But if you take pi over 4 and you subtract pi over 6, which would be 3 pi over 12 minus 2 pi over 12, you can see how that would equal pi over 12. So there's the difference that we're going to use. Pi over 4 minus pi over 6. Whoops, that should say sine pi over 12. Sorry about that. Sine pi over 12. So we will take sine pi over 4 minus pi over 6. And we can plug those angles into the formula. So we get, that would be sine pi over 4 times cosine pi over 6 minus cosine pi over 4 sine pi over 6. Sine of pi over 4 is square root of 2 over 2 times square root of 3 over 2 minus square root of 2 over 2 times 1/2. So again, we get square root of 6 over 4 minus square root of 2 over 4, and we get the same thing. Okay? Sometimes you're working it backwards. Here's an example where you just need to notice that they're using the difference formula for sine. Okay, so because it's sine cosine, that tells me that it's sine, and it's minus here, so we know it's difference. So we're looking at sine of just 42 minus 12 degrees. Which would be a sine of 30 degrees. Now, on your homework, sometimes they just ask for the trig expression. So if they ask for the expression, that's what they're looking for. But if they ask for the exact value, they want that. Okay. Now let's look up, if you look up right underneath the Pythagorean identities on your formula chart, you'll see the cofunction identities. So there's one of them, the cosine of pi over 2 minus x, any angle, equals the sine of that angle. Okay, so we're going to verify this. We can take the cosine of pi over 2 times cosine of x minus, that would be plus the sine pi over 2 sine x. So cosine of pi over 2 is 0 times cosine x plus sine of pi over 2 is 1 times sine x. So you can see that this is 0 plus sine x, or just sine x. Then the last one, we can do the same thing to solve, like we've been doing recently. So find all solutions on 0 to 2 pi to the trig equation, sine x plus pi over 4 plus sine x minus pi over 4 equals negative 1. So we're going to solve for x. So we've got two separate sum formula and difference formula. So I'll start with the first one. We can say that sine x cosine pi over 4, that would be plus cosine x sine pi over 4. So there's the first one. So there's the plus. Let's see here. Sine x cosine pi over 4. This one would be minus cosine x sine pi over 4. And all of that equals negative 1. So you've got 4 terms here. Hopefully you notice that you've got a couple of them here that will cross out. So when I combine like terms here, I get 2 sine x cosine pi over 4. And that still equals negative 1. Cosine of pi over 4 is square root of 2 over 2. We can multiply those, that'll cross out. So I'm looking at square root of 2 sine x equals negative 1. Divide the square root of 2, so we get sine x equals negative 1 over square root of 2. And then we can just rationalize that by multiplying the top and the bottom by square root of 2. Whoops. So x is equal to, what would that be? 5 pi over 4 and 7 pi over 4. There you go. That's how we will use the sum and difference formula. Have a good day.